This video is about graphing piecewise functions. So when we graph a piecewise function, we are only graphing each line in the region that is stated in domain. The domain is our inequalities. So in this case, these two are domains. It helps to first put a dotted line to separate the regions or use a highlighter. Each line is only allowed to stay in the specific regions, which means when we're graphing, we might not be able to start at the y-intercepts for each line like we're used to. So instead, we're going to have to create a table for our points. So to graph a piecewise function, the first thing you want to do is you want to look at your domains. And you want to figure out, based on the domains, what's being separated in the region. So any number that shows up in the domain should get a dotted line. So in this case, the only number that shows up in the domain is -2. So we're going to put a dotted line down -2. So this is separating the regions of our graph. So in this case, we're going to have a left region and a right region, which are going to have two different function rules. So the first function rule is 2x minus 1 when x is less than or less than -2. So when we are given this, we need a number less than -2. So in this case, I'm going to pick -3 because my slope is a whole number, so it doesn't matter what my x is. And then I'm also going to pick the number that's part of the domain, which is -2. So at most, how many numbers I should be picking for the first line would be one number because the other number is given to me from my domain. So I'm going to substitute those values into my function rule. So I'm going to do 2 times -3 minus 1, which gets me 2 times -3 is -6, minus 1 is -7. And then 2 times -2 minus 1. Well, 2 times -2 is -4, minus 1 is -5. So now I'm going to decide what kind of marking goes on the graph. So if it's part of the domain, it gets an open or a closed circle. If not, it gets an arrow. So at -3, -7, that's not part of our domain because our domain is x is less than -2, but it is a less than, so it's going to get an arrow pointing to the left. At -2, -5, that's part of the domain and there's no bar under the inequality, so it gets an open circle. So now we're going to graph this. So at -2, -7, I'm just going to put a little dot for now, and I'll draw the arrow at the end. -2, -5 gets an open circle, so I'm going to connect those points, and then add my arrow. So it points to the left, so I know that it's going away from that dotted line, continuing in the other direction. The second equation that we have then is -1/2 x plus 3 when x is greater than or equal to -2. So -2 we're going to use because it's part of the domain, and now we need a number greater than -2. So I'm going to pick 0 because it doesn't matter what I'm multiplying with, because 0 is always a good number to work with. So when I multiply and I substitute, I have 1/2 times -2 plus 3. Well, 1/2 times -2 is 1, plus 3 would get us 4. And then I also have -1/2 times 0 plus 3, which would get me 3. So at -2, that's part of the domain, so it's got a bar underneath the inequality, it gets a closed dot. And at 0, 3, it's not part of the domain, but this is a greater than, so we're going to want an arrow to the right. So we're going to go to -2, or +4, put a closed dot. I'm going to go to 0, 3, put a little dot so I can connect them, and draw my arrow. So let's try another piecewise function. Now for the problem below, there's a few new things to remember. So remember, when we have an f of x equal to just a constant without a number, like down here, this means that we're going to have a horizontal line for each y value. So no matter what x value it is, the y value is always going to stay the same. Now, when we have the notation -1 is less than x, which is less than or equal to -2, this means that the segment is going to start at -1 with an open circle or an open dot because it doesn't have a bar under the inequality. It's going to end at 2 with a closed circle. So these are the two coordinates that should show up in our table because they're giving us two parts of the domain now. So in this case, the domain, the numbers that we have are -1, 2, and 9. So we're going to put dotted lines at -1, 2, and 9. And the dotted lines are just there to remind us of the different regions. Every time that we're on a dotted line, though, it's helpful to remember that that should have have a circle either open or closed. And if it's not on a dotted line, it should have an arrow at the point. So the first equation, we have 5x minus 1, and they gave us two numbers in the domain. So we're going to put both of those numbers in the domain, -1 and 2. So I have 5 times -1 minus 1, which gets us -6. And I have 5 times 2 minus 1, which gets us 9. So looking in this domain, we have -1 is less than or equal to x. So because there's a bar underneath that -1, we're going to get a closed circle. And at 2, there's no bar underneath it, so it's going to get an open circle. So this case, there's not going to be an arrow because both points are on a dotted line. So we're going to go to -1, -6. We're going to put a closed dot. We're going to go to 2, 9. We're going to put an open dot, and we're just going to connect those two to get our line. Then we're going to move to the next equation, which is just -8. So this is a little bit easier. We have 2 points for our x's for our part of our domain. We have 2 and 9. And 8 has no x, so both of them have a y value of -8. So it's going to be a horizontal line. Now, at 2, there's a bar underneath for the inequality, so it gets a closed circle. There's also a bar underneath the inequality by the 9, so that also gets a closed circle. So we're going to go to 2, -8, put a closed circle, and we're going to go to 9, -8, put a closed circle, and then connect those 2 points to create our piecewise function. Now remember, a key part about graphing piecewise functions is to only graph the portion of the graph in the domain listed. Also be careful that you know when you have an open circle or a closed circle. So now we're going to graph. We're going to remember to show the domain on the graph, make a table, and then use our points to make the rest of the line. So in this case, the numbers that show up in the domain are -8 and -3. So those are both going to get a dotted line. So we're going to go to -8, put a dotted line through, and we're going to go to -3 and put a dotted line through. So in the first equation, we have 5, and our domain is from -8 is less than or equal to x, which is less than -3. So because it gives us two values, those are going to be our x's. Because 5 has no x with it, those are going to be our y values. So at -8, the inequality sign by -8 has a bar underneath it, so it gets a closed circle. The inequality sign by the -3 has no bar underneath it, so it's an open circle. So we're going to go to -8, 5 and put a closed dot. We're going to go to -3, 5 and put an open dot. We're going to connect those 2 points. Then the second equation is 5x when x is greater than or equal to -3. So one number we have to use in the table is -3, and then we have to pick a number that's greater than -3. Well, an easy number to work with that's greater than -3 is 0, so I'm going to use 0. So in this table, in the section is my little work part. 2 times -3 is -6, and 2 times 0 is 0. So at -3, it's part of the domain, and it has a bar underneath it, so it gets a closed circle. 0, 0 is not part of the domain, but it's part of a greater than inequality, so it's going to get an arrow to the right. So we're going to go to those points, -3, -6, put a closed dot, 0, 0, put a little dot to connect our lines, and then add our arrow. Number 4, now number 4 has 3 different functions, and they have -5, 4, and 10 in the inequality. So we're going to put our dotted lines at those. So at -5, at 4, and at 10. And then the first equation, we have x is less than -5. So we need a number less than -5. So I'm going to pick something close to it. I'm going to pick -6 because there's nothing in front of the x, so it doesn't matter if it's a multiple of something or not. And I'm going to put -5. So I have the absolute value of -6 plus 5, which is -1, and the absolute value that is +1. And then I have the absolute value of -5 plus 5, which is 0, so our y-coordinate is 0. So at -6, it's not part of the inequality, but the inequality in the domain is a less than. So we're going to get an arrow pointing to the left. And at -5, it's part of the domain, and there's a bar underneath it, so it gets a closed circle. So we're going to go to -6, 1, put a little dot for now. We're going to go to -5, 0, put a closed circle, and then we're going to connect those points and add our arrow. Now the next part of the function is 2x plus 1 when -5 is less than x, which is less than or equal to -4. So this one gave us two numbers that are going to go into our domains. We have -5 and 4. So 2 times -5 plus 1 is 9, -9. And 2 times 4 plus 1 is +9. So at -5, there's no bar under the inequality, so it gets an open circle. And at 4, there is a bar under the inequality, so it gets a closed circle. So we're going to go to -5, -9, place an open circle. We're going to go to 4, 9, place a closed circle. And then we're going to connect our two circles. The last part of the function then is x when 4 is less than x, which is less than or equal to 10. So the two numbers that we're going to put as our x values are 4 and 10. And when I substitute that in for x, I get my y value is 4 and my y value is 10. So at 4, in the inequality, there's no bar underneath it, so this gets an open circle. And at 10, there is a bar, so it gets a closed circle. So we're going to go to 4, 4, and put an open circle. We're going to go to 10, 10, put a closed circle, and then connect those pieces. Let's look at one more example. So in this example, notice that all of them have just constants for the point. So in the first inequality, we're going to look at, we have -7, -3, and then we also have 1 and 5. So we're going to put dotted lines at all of those. So we're going to put a dotted line at -7, a dotted line at -3, a dotted line at 1, and a dotted line at 5. Now, because they gave us 2 points in each inequality, we're going to go at our x's for the first one are going to be -7 and -3, and the y values for both are going to be 5. At -7, there's no bar under the inequality, so it gets an open circle, and at -3, there is a bar, so it gets a closed circle. So we're going to go to -7, 5, put an open circle, 3, -5, put a closed circle, and connect those. Then the next one, the two numbers in the domain are -3 and 1, and both of those y values are -1. Now at -3, there's no bar, so it's an open circle, and at 1, there is a bar under the inequality, so it gets a closed circle. So we're going to go to -3, -1, put an open circle. We're going to go to 1, -1, put a closed circle, and connect those points. And then the last one, the domain numbers are 1 and 5 for x. The y values are -7. So at 1, there's no bar underneath it, so it gets an open circle. And at 5, there is a bar underneath it, so it gets a closed circle. So we're going to go to 1, -7, open circle, 5, -7, closed circle, and connect those points. This models a step function. because it looks like stairs from going from one to the other.